Okay, this question directly all the basic things are given like kg meter cube, all these fundamental quantities we have, that format is given. In second type of question they have given derived unit, okay, and we have to like this also derived unit only, but it's very simple, directly you have to put here. Okay. Let's see in second type of question how they ask. Convert 1 or let's say 1 Newton into CGS units, right? Correct. 1 Newton we have to convert into our CGS system. Now, what's the difference between this question and this question? Here directly we know kg meter given, I did put here. Here Newton is given. So first you have to understand that Newton is the unit of what? Force, correct? Then you write the basic like kg meter format of the force, and same procedure we have to follow. Okay, Newton, they said Newton is unit of what? We know force. So you write this force units in derived or what? Fundamental format. So how we write? We know force is equal to whatever formula we know, we can write ma, m is kg, acceleration is meter per second square, so meter per second square. This is the okay derived format. Okay, so let's write same formula again. N1 U1 is equal to N2 U2. Okay, N1 numerical value given system is what? 1 Newton. Let's put here 1 unit. Newton given, we writing into derived format or fundamental format like this way, kg meter by second square is equal to N2 we have to find always, and unit in the second system. Second system is given what? Your CGS. So how you call these things only in what? CGS. Kg you call as gram, you wrote gram, meter you call as centimeter, second you call as second only, right? Again we have to cancel on both sides and get the numerical answer. So look here, 1 kg into gram is easy, I can write just 1000 gram, okay, meter I can write as 100 centimeter, and time is same only on both systems, second square is equal to N2 gram into centimeter by second square. Okay, time goes here, gram goes here, second goes here, right? Everything goes. So here remaining is what? 1000 into 100 is equal to what? N2, or N2 becomes 10 power 5. Okay. Yeah, this is a numerical value of 1 Newton into CGS system. And if you have to write units here, we can write same format like this SI unit. So kg means gram here. We just finding numerical value only actually, so should not write unit here, but even they ask in unit we can write, because this much kg suppose they ask proper value, then how will write? It will like 10 power 5. This unit write is SI, let's write CGS, gram centimeter second square, right? That will be your answer, right? As a 4. This is just numerical value only, okay? Like in this question I wrote here, so I should not write like this way, because it's a number only, I should not write unit. If they ask like what is density rho, then you should write 0.01 gram per centimeter cube. That will be the more appropriate answer, right? Yes, here you are just finding numerical values only. Okay, okay, I was talking about some derived unit which are very popular for us, so we have a special name for them also. Okay, so like these two things only you have, so I am writing them. So one is for unit of what? Force. Force in SI is called what? Newton, we know, right? We measure into what? Newton. And in CGS is called what? As dyne. And how they are related? We just found that 1 Newton was equal to 10 power 5 dyne. So 1 Newton is equal to 10 power 5 dyne. This is the relation between them. So we have special name. We can write like this formula also, gram centimeter by second square. But we have a proper name here, dyne. Similarly, energy or work, these things also we have. So SI system we call it joule, correct, and CGS system is called what? Ergs. Yes, and they are also related. 1 joule is equal to 10 power 7 ergs. This relation we can find like we have found for force. We just calculated that 1 Newton into CGS comes what? 10 power 5 dyne. Same way we can convert like 1 joule into what? Erg system. we will get that answer. Let's do that because that type of question was also asked. Okay, let's discuss this question. Third question we are talking. It says that convert 1 joule into CGS system. Correct? Yes. 1 joule you have to convert and we have to get that answer because already I wrote it here. 1 joule is equal to 10 power 7 ergs in what CGS system. Okay. Yes. So let's convert same rule. First joule given, we have to write into kg meter this format. Okay. Let's write. We know joule is nothing but what unit of what energy and energy. Right. Write any energy formula which you know, energy or work, any formula which you know. Simplest we can talk potential energy mgh or kinetic energy half mv square, whatever we know. Let's write here, like write kinetic half mv square. This is a constant, has no unit. Mass kg, velocity means meter per second, and square is there, so meter square and per second square. Okay, like this. This is a what derived or in terms of what, like fundamentals. Okay, yes. Now we have to use the same rule to answer this question. Let's write here N1 U1 is equal to N2 U2. N1 means 1 joule you're talking, so 1 joule unit means what we wrote here joule kg meter square by second square is equal to N2 we have to find. We converting these into what CGS system, so N2 we have to find, and how you call these into what CGS system, the same unit only. These are SI system, we have to write into what CGS. Kg is called gram, yes, meter is what centimeter square, and time is second square only. Again same procedure, we have to cancel on both sides and get numerical answer. So and kg you can write as 1000, gram, meter you can write as 100 centimeter square, and second you keep second only because they are same on both system. N2 here, okay, gram, centimeter square, second square. Let's cancel on both sides. Gram seconds goes here, gram goes here, second goes, centimeter goes here. Okay, 1000, then here 100 and square. Give attention to the powers, 100 and square. So 100 into 100 is equal to what? N2. So 1 0 2 0 3 4 5 6 7. So N2 is coming what? 10 power 7. That's the numerical value of 1 joule into what? CGS system, which I already wrote here. 1 joule is equal to 10 power 7, and name also here what? Ergs. These two are very popular, so you have to remember these two, that 1 Newton is equal to 10 power 5 dynes in what? CGS system, and 1 joule is equal to 10 power 7 ergs in CGS system. We have name. Others we can write like in this format, combination of what? Fundamental units. Okay. Yes. So these were two pattern I have discussed, like one directly basic format is given like kg meter cube is given like density equation we have done, or some derived type of like joule is given, Newton given, Pascal given. You have to write their basic formulas, any formula which you know, and write into what, like fundamental format, kg meter second format, and use the same equations or this relation between what? Quantities and what? Units. Okay. Now let's move to the one more pattern they have asked, in which look, these questions I have done. Here what they are doing, they are giving name of the system like the, you know, joule SI system, and they are giving the converter what? CGS system. The name of the system is given. In third type of question they did not give the name of the system, they just directly gave some values. Okay, let's see how they have given. Okay, we doing now the fourth question on this same relation, and in this question how they have asked the same question only, like they don't give the name of the system. Like they say that convert 1 joule into some system, and they don't say like convert into CGS. They say like in this system length is measured like this value, mass is measured like this value. They give directly some their own unit, imaginary unit. Let me write one question, you will understand. Let's say that convert 1 joule into a system in which the unit of length is 10 centimeter, unit of mass is 50 kg, and unit of time is 5 minute. Okay, let's understand this pattern. Again they asked to convert some value. We know 1 joule SI system, yes, but second in which we converting, they did not give the name of the system, directly giving that how we measuring these values. Unit of length is given 10 centimeter, unit of mass is given 50 kg, unit of time is given what, 5 minutes. Some combination of different CGS and SI will be given to you. Okay, yes, and this is a recent pattern. Okay, yes. Okay, how we answer this? Procedure will remain same. Let's write formula. N1 U1 is equal to N2 U2. Again first joule given, we have to write into kg meter format. So joule again unit of what, energy. So any energy formula you wrote, like last time I wrote kinetic energy, you can write any energy. Potential, let's write potential mgh, right? M is kg meter per second square and h means what, again meter. So this become kg meter by square by second square. This is a unit of what, joule, into this kg meter format. Let's put it here. Okay, numerical value n is given what, 1. Okay, 1 unit which is kg meter square by second square, right, is equal to N2 we have to find. Now what is the unit in the second system? Like in previous question they said convert into CGS. So same things I wrote it just in CGS, but here already they gave how we measuring the second system. Okay, kg mass, how they measuring mass? The unit of mass is what, 50 kg. Directly you will put what here, 50 kg. Done. Okay, yes. Length, meter, how length is measured here? Length is measured as what, 10 centimeter. You directly put what here, 10 centimeter and what, whole square, power you have to put here. Okay, how you measuring time? Second, time is measured as what, 5 minute. Unit of time is given 5 minutes. You put here 5 minute and here square. So whatever units are given, directly putting it for here. Now procedure remains same, you have to cancel on both side. Okay, okay, 1 here we have kg, here we have kg, you can cancel directly, no problem. Meter and centimeter, that we can convert, we can write 100 centimeter and what, square. Here we have second, here minute, minute is easier, so we can convert on this side. So I write second square here itself. Okay, and to kg got cancelled, 50 remaining, 100 centimeter and whole square. 5 minute, so I am writing 5 into 60 second and whole square. Now this centimeter and these seconds we can cancel. So you see this side we have 100 square, so this become 100 into 100. This side we have n2, on top remaining is 50, then 10 square, so this become 100, and down we have 5 into 60 which is 300 and square of this, so 300 into what, 300, 5 into 60. Okay, yes. Okay, so we have to find n2, like 1 2 3 zeros, 1 2 3 0, I can cancel it here. Okay, 5 goes here 2 times, so n2 will be simply equal to 2 into 300 into 300. 300 into 300 become 9000 and is what, 18. So 18 into 1020, right, this much. So that's the numerical value of 1 joule into this system. Correct. This is a third pattern in which they don't give the name of the system, like convert 1 joule into CGS, not like this. Convert 1 joule into some system in which unit of length, mass and time will be given to you. You will directly put in this formula and cancel on both sides to get your answer. So these are the 3 patterns. So total 4 type of questions we have done, if you remember, based on this relation between physical quantity and unit. One relation, that how n and u are related. So I saw that n and u are what, inversely proportional, because nu part is always constant. This is always constant. Q is equal to nu, or you say is what, always constant, because when you changing anything from here, this thing doesn't change. If you change u, n will change automatically, or you change n, same way u will change automatically. You increase u value, then n will reduce, or you reduce n, then n will increase, right? Yes. Okay. So here we finish about what, our fundamental quantities, units and the derived units. Okay. Now we have to talk a little bit about the third type of quantity, which are called what, supplementary. So now we are talking about the third type of physical quantities, which are called supplementary units. Quantities, and same we have units also for them. Supplementary, these are also actually fundamental only, because here we talk about units of what? Angle. Okay, yes, so they are also independent, but they are written in real in terms of what? Fundamental only, but they are also almost basic units. Okay, and what they are, we have two type of this. One is called unit of what? Angle, or physical quantity is called what? Angle, and unit of angle is called radian. What is radian? In junior classes, you measuring angle between two lines, you call it like degrees, 50 degree, 30 degree, 45 degree. So degree is not again the SI unit. SI unit of angle is what? Radian. Correct? So this radian, which is unit of angle, we can call it properly 2D angle. What angle? 2-dimension angle. And what are 2-dimension angle? Like all the pictures which we draw in our notebook, which has length and height only, those are what? 2 dimensions, right? All the objects we drawing, all the pictures we have in our books, they are what? 2-dimensional picture, right? So when you're talking the angle, 2-dimensional angle, okay, or you say plane also, we have to talk unit about what? Radian, correct? And you know radians written always in terms of what? Pi. So in junior classes we are doing angle in terms of what? Suppose these are two lines, and this angle you have write, generally we wrote like this is 30 degree, 40 degree, 45 degree. So degree is not SI unit. Once more, SI unit will be what? Radian. So in whole physics, now wherever a formula comes and we have to put angle, try to put in what? Radian. Okay. And how we define this? Let's write formula for this. Suppose this is circle, and somebody start from point A and he moves along the circumference and come to this point B. Okay, so that much distance travel, we call it what? Arc length. Let's represent by S symbol. S is what? Your arc length, and this is the radius R. This is the radius R, right? R is the radius of this circle. Yes, so this is the angle covered. Let's call it what? Theta. We write theta symbol. Yes, theta. So what is that theta? What is the definition of theta? This theta is nothing but what? Arc length by radius, means S by R. That's the formula of what? Your theta. So when you are dividing arc length by radius in a circle, you should write what? Theta, means you should write into what? Radian, not degrees. If you want to convert, you need to convert, you can convert, but you should write what? In radian. Radian is the SI unit of what? Angle. And now what happens? Why this is not included into those 7 fundamental? Because if you see that this is what? Length by length only, radius also length only. So these two are what? Actually 2 fundamental quantities, right? So combination of fundamental is called derived. So we don't give their name, these are special use, so we call them what? Supplementary. Okay, in real they are also almost like fundamental. Okay, now formula we have seen, theta is equal to S by R. Okay, radian is equal to what? Arc length by radius. Okay, this much only we have. Now what question they have asked on this alone? Yes, they have asked 2-3 questions to us. We will talk about them. There is use of this formula in our rotation chapter and all other chapters also, but direct question we are talking that alone from this chapter what they have asked. Yes, they have asked some questions, we will talk about them. Okay, before I just want to tell you how you convert degrees into radian, radian into degrees. If you don't know, okay, you may need it. So you know that, suppose if I say pi means how much? This is a radian, right? Pi is what? Radian. So pi is equal to how much? You say 180 degree, right? Like these things we know. So how to convert them into for any angle? If you know degree, you have to convert radian, radian into degree. So I am writing some things here. Let's see. So radian is what? How you write radian? Radian is simply equal to what? Like pi by 180 into what degree? You want to convert degree into radian, then what you will do? Whatever degree given to you, multiply with what? Pi by 180. You will get answer in what? Radian. How? Suppose I say 90 degree is what? You put 90 here. Pi by 180 into 90, it becomes pi by 2 radian. So this is the relation between what, or opposite you want to do, you say how you will what is degree, degree will be what, then you go opposite 180 by pi into what, radian. You put your radian here, you will get answer in what, degree, right? Yes. Also this is a simple thing, sometime in physics we will need this degrees and this angle in terms of what, time. Yes, you can also write this angle in terms of time. So what is the relation I am writing here? Okay, so I am writing how you write degrees in terms of time. So what is the relation? 1 minute is equal to 60 degree. 1 minute is equal to 60 degree, or you want to write opposite that, what's the meaning of 1 degree? Then it says what is equivalent to what, 160 minute. Yes, or I say what is 1 minute is also equal to what, 60 seconds, right? So how you will write in degrees? So we are writing the time and degree relation, because we will need somewhere in physics. So what's the relation? That 1 degree is equal to 60 minute, or you can say 1 minute is what, 1 by 60 degree. Also suppose you want to write in terms of second, then 1 minute is equal to 60 second. 1 minute is nothing but 60 second. So how degree and seconds are related? You can also say that 1 degree should be equal to what, 60 into 60 means 3600 second also. This is degree and what, time relation. We need to convert, we need to use them somewhere in physics. Okay. So when we are talking about this chapter alone, that this is the formula of your angle, and what question has been asked on this? Yes, there are 2 questions that have been asked on this. We will talk about them. Okay. So now we are talking that the basic formula of angle, which I wrote like this, is circle, and you cover some distance which is called arc length s, and this is the radius r. Then how this angle related? You say theta is equal to s by r. Now we are talking that what type of question they have asked on this alone. Okay, here. Yes. So one question was asked to us like this. Using this, we can find distance of a very far object, or we can find the diameter of a very far object, like you can find the distance of the moon, or you can find diameter of the moon. So like how they have asked an exam, suppose find the distance of some, let's say, moon or some far object. Okay, yes, you want to find distance of what, some very very far object. Yes, you can use this formula. How? Suppose this is your moon, here is the moon, yes, and this is our earth. Okay, then what we do to find the distance of this? You watch the moon from one place, let's say here is Chennai, we are watching moon from Chennai, so this is what, Chennai. Then you go to some other city, let's go to Mumbai, and you watch same thing again from here, right? The distance between these 2 things we know. Distance between Mumbai and Chennai, means distance between 2 places we know. Let's call that s. Distance of this moon, let's call it what, r. This is the angle made between these 2 points, points, this angle subtended, that we can measure with help of our instrument, right? Now telescope or whatever we are using, we can find that angle. Okay, so now what we know? We know this angle, we know the distance between 2 places from where you are watching that far distance object. This thing is unknown. So if you see that whatever this small triangle we have made here, that's almost looking here, this is a triangle, right? This is a distance between 2 cities. Same formula right here, theta is equal to s by r. Here theta we know, s means arc length or the distance between 2 cities we know, and we have to find what, radius. So radius or the distance, this like radius we are writing here, this is what, simply the distance of the moon. So your r will be equal to s by theta. That's your answer. So in the questions they will say like this, that the far object or moon is observed from two places on earth which are situated at distance of some kilometer will be given, and the angle subtended by these 2 points on moon will be some radian will be given, or degrees given, then you have to convert first into radian, because here you have to put only radian. This will be very small angle, like 0.000 something, okay, very small. And so we have to find the distance of that object. So this r we have to find radius of this. Like look at this picture and this picture, they are actually looking almost same, right, like a sector of this circle, right. So here we know distance between two cities, Chennai and Mumbai, we call it arc length, and the angle subtended by these 2 points on the moon, which we know what theta. In theoretical, this is called a parallax method. You watch same point from 2 different positions, then angle you can find subtended, then you do know distance between these 2 places, so you can find that distance r, okay. So this is a way to find the distance of the far object. Okay, same question was asked in opposite way. Distance of moon is given to you and angle subtended is given, we have to find what is the diameter of the moon. Then the same picture we have to reverse it. How? So this question can be asked, or it was already asked actually. Find, suppose, diameter of the moon. Then how to find? Look here. This is your moon. This is our moon. That's the diameter of moon. Let's call it d or whatever. And this is our earth. Okay, again. This is our Nama Chennai, our Chennai city. Now what we do? Watch the moon's this end from the Chennai like this. Then you watch the other end of the moon like this. Okay. Yes. This angle that this diameter will sustain, we can calculate with help of our instrument. Okay. This is theta. So now what we are doing, from same place only watching the 2 sides of the moon, that end and this end. Okay, this is the distance of the moon, let's call it what, r. That's the diameter of the moon. So now look here, same sector is formed here, same picture is here again. This is angle, that's your radius, this is what your arc length almost. So same formula you write, theta is equal to s by r. S means arc length, which is what, diameter here, d, and radius means what, the distance r. This time the distance of moon is given, they are asking to find diameter of the moon. D we have to calculate, and distance of the moon and angle subtended will be given to you. So your D will be simply r into what, theta. That's your answer. This actually both are same thing only. Here we are finding distance of the moon. Just like radius we have to find, arc length we know, angle subtended we know. These 2 things will be given, this we have to find. Here just opposite, this triangle just goes reversed. Here we have to find diameter of the moon. So from same place only watching this end, then this end. So again we see a triangle here, this angle subtended, that's a distance r or like radius, that's what diameter or what, arc length. So same formula, theta is equal to arc length by radius. Arc length means the diameter, length means what, distance between moon and what, earth. So these 2 things will be given to you, you have to find what, this one, correct. So these 2 questions they have been asked directly alone from this chapter. Then this comes in every chapter of physics, because radian will be is SI unit of angle, it comes in every part of the physics. Okay. Okay. So here we do what, our angle. Now there is one more thing. Okay. Second supplementary unit is called what? Unit of what? Solid angle. Solid angle. As I said, this is the angle is what angle? 2D angle, 2-dimensional angle. Okay. Yes, radian. Solid angle. Mainly engineering people learn this, as we NEET student, this is not much important for us, still we learn few things about this. Yes, solid angle is what? Angle for what? 3D objects, 3-dimensional objects. Yes, real life objects, for them angle we write, yes, solid angle. And what is unit of solid angle? Steradian, STE and radian. So just before the radian putting one more word, STE, steradian, right? Okay, like you have a cone, this is a 3D object, you have a cone, then this angle of this cone is measured in what? Steradian. This is called solid angle. This is called area of the base, we write A symbol, thus height or radius you want to call r. Then how this theta is given, solid angle is given, what is the formula of this? Is called area of the base. This is the base which subtend an angle. So we are talking about area, and whatever this radius or height also say sometime radius square, a by r square. That's what your stay radian unit of what? Solid angle or 3D objects angle, right? You have a cone, this cone like a circular type of base it has, the cone can have like a square type of base also. Suppose you talk about this type of things, okay. Then you will see this is square type of base, so suppose side is given a, then area of this object will be what? A square, right? Here area will be like pi r square, you have to put pi r square here, okay. So this is used for what? Solid angle. And so far when I talk NEET, nothing was asked about this, okay. Nothing was asked about solid angle. This is more important for what? Engineering students. Yes, so to us they did not ask any question, but even they asked, here is the formula. Theta is nothing but area of the base by radius square, area by radius square. Area depends on what type of area, like here circular area, so you have to write pi r square. Here is a square base pyramid, so area of the square you have to write, which is what? A square, right? So depends on situation that what is given to us, area of the base by radius square. So this is our solid angle, and here we finish our the first topic, units and physical quantities, right? So when I talk from exam point of view or NEET exam, the first part is even not that much important. Mainly they are asking questions from what? Third part, which is measurement errors, and then what? Dimensions. So in next lecture we will talk about dimensions completely, and third lecture we will talk about measurements, means errors, which are the more important from exam point of view. So hope you understood the basics, and there is not much numerical practice on this. Whatever I discussed with you, these are the only things we have, okay.